All right, April 3, 2017. This is a look at LED faucet lights and what might we be able to do with these things. So this is a LED light that hooks onto the kitchen faucet or other faucet and has a little turbine in it that generates DC current that lights up LEDs. Appears to have a temperature sensor in it as well, that when the water's hot it's red and when it's cool it is blue. These are from eBay or Amazon. I'm not sure where I got this. They're about $2, I think. And so here's one out of the box we can look at to start with. So it's got a filter, which is keep the crud out, screws into the faucet, and so we can make it light up if I put this hose on here so I can blow in it easily. Let's see what happens. You can see it light up from blowing on it, and of course with water it works even better. And so the idea is that if I can tap into the generated power, I could put some other sensor in there and possibly have a small low power radio that sends a signal that tells me when the water is on and maybe what the temperature is, although I'm not sure that I'm going to be able to keep the current electronics. I really just want to keep the generator, put my own electronics, and then be able to send a signal far enough so that I can maybe plug something in to a kitchen wall socket, wall plug, and catch the signal that says the water's running. And then if you do that for all the faucets, you can add up or estimate current consumption. So if we take this apart, we can have a look. And I've taken one apart, which I've been picking at, and it's not real easy. I haven't got the one completely apart, but having these little hooky picks helps. So this first piece is a little deflector that converts the linear water flow into a swirl that turns this turbine. In order to get the center out, the first one I tried to push it out, press it out this way, and it broke out. This front diffuser, water diffuser, seems to be glued in, so it broke that out, and it appears they're assembled this other way, so we can get it out by hooking the hook behind this like this and pulling on these little trunnions, I guess they are, trunnion-like alignment bosses. And so here's the little device. So we've got what appears to be a thermistor here for temperature. Looks like an epoxy thermistor, and at least a two-color LED, blue and red. I haven't seen any other colors than blue and red. And if you look at the graphics on this, we've got red and blue, and that's it. And on the back it says multiple color, and then the three letters RGB appear in there once, and it's got lots of instructions, but that's not the part that I'm interested in. And then we can sort of fire it up if we squirt a little air at it or whatever's in these cans. So you can see it turn green there momentarily. I don't know what the green's about, but in any case, so the next step is to try to break through this potting to expose the circuitry so we can hook onto it in such a way that it can be resealed and that we don't let water get into the generator and make it fail. So there's this LED, which we saw three colors, red, blue, and green. and we need to work on that. So the one that I started working on, I have here in the vise. We can start to have a look at it. So I've got this one partly disassembled. Let's have a look. And so we can see the turbine, and I've got the top cut off. I cut around it so far at the level that you may not visually be able to see. I cut around with the little hacksaw right at that level, which looks like it might have been a little bit too deep. We can see I've got some circuit board exposed, and I've broken off the thermistor. So now we see, if I spin the turbine, it blinks red all the time. So what that's telling me is that the thermistor, when it's reading the thermistor, and it's indicating hot all the time because of that, which again we don't care about. It may turn out that this can be removed easily just by knowing the level. As I start keep picking down through here, I may find that it would seem like I'm going to find that there's two wires that go to the generator that's below, and if I can get to that layer without breaking the seal, then I can put my other circuitry on. So you can see this LED, I almost have it exposed down to the board, and I haven't made it so it doesn't work yet. I've knocked off some capacitors. You can see on here, this looks like a microcontroller, and you can see what looks like might be a tantalum capacitor, the top right here, and you can see I've cut through. I've knocked a resistor or capacitor off here, and some other components have been knocked off. So if I can pick this down far enough to be able to see more. So this is the sacrificial one here. The idea is to discover where exactly to cut into this to be able to pick data out, and then if I can get two wires to come out, ground and power, then I can seal it back up, put it back in, and maybe make something that has another little wart on the side of this to experiment with having a radio that's strapped on the side. So maybe something that's as big as two of these side by side on the faucet for experimenting might be good enough. And then of course it can be made small if you can get a hold of these before they've been potted or before they've added the circuit board to it. Then you could use this as a basis for a product. But I'm now to the stage where I'm just trying to pick it apart slow enough so that I can learn more about where to attach to it. This potting compound smells like acrylic caulking that's hardened. So that tells me that this is acrylic potting compound. And so it's possible that there's a solvent for this that I'm not aware of. You can see there's a plastic case. They've put the motor in, and then they've put the board in, and they've poured the acrylic potting compound, which has shrunk. You can see the meniscus around the edge here where it's shrunk down, which I think may also hint that it's acrylic, because I believe the acrylic loses water when it cures. So that's what I think this is. So if I can get acrylic solvent, I might be able to dissolve this out, and then all the electronics will be intact. It'll be easier to hook on. But anyway, that's the current state of the inside of these, and it looks possibly at the first step might be to try to get this LED out really carefully. This LED is going to have 4 pins, ground or common, red, green, and blue, and then that is another place to pick off power. But then this other device, this microcontroller that controls the blinking and the color, is going to be wasting power. We'd like to just get the raw power and harvest that energy for whatever water-based measurement circuit that we want to build. Anyway, August 3rd, 2017. This is a look at LED faucet lights.